there is currently a movement of people that arguably was started by people like Eliezer Yudkowsky and others who reason themselves into the conclusion that when AI is going to happen, and that's almost inevitable because it's valuable and it's physically possible, then it's almost inevitable that it's going to be agentic. And if it's agentic, it's going to be self-improving. And if it's self-improving, it's going to compete with us. And because it's smarter than us, it will win against us and we will all die. And because Eliezer did not see a big hole in this chain of reasoning, a lot of people who have the mental property of believing in rational thoughts very, very literally freaked out and started to panic and started a movement against AI, and then now try to, for instance, write regulation that ostensibly exists to make AI safer, but is actually designed to hamstring AI research in such a way that it gets slowed down or stopped. That is the hope, because they don't believe that you can make AI safe. They actually believe that it's almost inevitable that AI will get better and better if you continue researching on it. So it is going to inevitably destroy us all.
Hello, this is Robinson Erhardt here with the introduction to Robinson's podcast number 219. And this episode is with one of the most requested guests of all time, and that is Joscha Bach. Joscha is a computer scientist and artificial intelligence researcher with an extremely active mind who is currently working with Liquid AI, though he's previously done research at Intel, MIT, Harvard, and the AI Foundation. This episode is quite wide-ranging. We start off by talking about Joscha's background, though we quickly move into a number of other things, such as the nature of consciousness in animals and machines, various theories of consciousness like Panpsychism, physicalism, Dualism, and Roger Penrose's theory, intelligence and artificial intelligence, the current wave and future developments of ChatGPT and other technologies, and then whether advances in AI could spell the end of humanity. Now, full disclosure, I know very little about computer science and technology, so I'm quite grateful to Joscha for bearing with me through this. Otherwise, I am dreadfully close to a 5-star average of reviews on Apple Podcasts. So if you're listening on that platform, please leave a review or just type in, hit the 5-star button, because it would be extremely helpful. Also, there's a link in the description to the Patreon where you can get access to ad-free episodes, show notes, and the ability to ask AMA questions. The next installment of which is actually slated to come out later this week. So now, without any further ado, I hope that you enjoy this conversation as much as I enjoyed having it with Joscha. From listening to you talk, and I just looked at your Twitter again before I came here, it is so apparent how much you love computer science and artificial intelligence. It's clearly just a vital part of your life. And before we talked about those things, I wanted to hear a bit about just how it became part of your world.
I started programming very early, and in a way, I started coding with Legos.
With Legos?
Yes, Legos already have this idea that you have a world that is fundamentally discrete, made out of relatively simple blocks that you can combine without trying to subdue nature, but only trying to express your thoughts. And with Legos, your ability to limit your thoughts, of course, limited by the set of building blocks you have, how many you have, what kind of arrangement I have, what properties I have, and so on. But they, in some sense, have blocks and slots. And by planning ahead, you can construct. And so there is this fundamental act of producing an expression of your ideas via construction. And when computers entered my life, that was at the age of 8 or 9, I saw a TV show about computers and programming. And I was smitten because I thought this is basically like Legos, only it's completely abstract. So you can express any thought that you want as long as you're able to translate it into a general language. and you can put anything on screen with it that you can imagine, and it can occupy any kind of space. And there is absolutely no limitation in terms of the building blocks that you've got, because you've got all of them. You just need to know how to combine them. There is absolutely the only limitation that you have is the memory of your computer, which back then was a real issue. And then, of course, the speed of the computer, which means how patient are you going to be in looking at the stuff that you are generating if it takes very slow to produce the result that you want to have. And then about a year later, I got a Commodore 64. I already had learned coding by that time, and pestered my relatives to get one to me from Western Germany, which was quite difficult back then. And I was forced to go very deep relatively quickly, because the Commodore 64 does not even have a command to make a line, and it's this basic language. And the basic language itself is relatively close to machine language. It's not that far remote in the way in which you think, because there are not that many abstractions available. It's relatively close to the metal. And when you have to learn assembler to produce faster things, you really get from the ground up and realize that at the bottom of your CPU there is an automaton, and this automaton allows you to build a representational language on it in which you can express anything that you want to the degree that you actually understand it. So it's a tool to develop your thoughts in an extremely rigorous manner and test them, but it's also a tool to build anything that you want in this virtual world of the computer. And there were some concepts coming from this world of the computer that didn't make a lot of sense to me. In the world of mathematics, for instance, I didn't really understand what space is. I understood that space is a reference that our mind is building, because it's basically, we would say today that we are training a neural network into our mind that is basically a black box. That is, it's not completely a black box. We have some idea on how V1, V2, V4, and so on represent stuff and how they are related to each other. But from the inside, we don't see any of that. Right? We notice that there are textures at some level, there are geometries that are moving, and we can start paying attention to how our mind is constructing a space. But it's basically just a machine learning tool that is trying to make sense of an extremely heterogeneous world. And so when I try to grasp the concepts that mathematicians use for geometry, they seem to be quite opaque to me, because they're actually quite difficult to express in a computational language from the ground up. It's not easy to construct geometry. It's much easier to construct logic. And so this intuition that you get in school that geometry is easy, because your brain already knows how to do it and you just need to refer to it, and mathematicians already have these intuitions and they seem to be platonically given. And then, on the other hand, you have this logical language from which you can build geometry, but it's actually hard work. And then realizing actually the hard work has been done by your brain in a way that you couldn't see, and it's not given. And algebra is actually much more easy than geometry and much more fundamental. And the true algebra is, in some sense, code that can express anything, and some of what it expresses, a tiny bit of it, is geometry. And geometry happens to be the way in which we model the visual world. And it's an important part of how we model reality, because it's grounding our symbolic representations. Right? But it's necessary to understand both. And I wish that mathematics or philosophy would have given me an inroad into this. But in some sense, I think that the progress of mainstream philosophy in understanding mental representation more or less ends with Wittgenstein.
Oh, really?
Yeah.
That long ago?
Yes. I don't feel that when you are taking a normal philosophy curriculum in university and you want to understand how the mind works and how mental representation works, you may get to, say, the debate between Fodor and Perlichin about whether the mind is representing things in a language or in images. But from the perspective of a mainstream computer scientist, this is a ridiculous simplification. Right? Because of course it is a language, otherwise you couldn't represent it. And of course the language represents something that we interpret as images. So for instance, geometry. So geometry with additional attached semantics. And in some sense, this is so obvious that the case is closed for computer scientists when they think about how to build a system that represents reality. But it's completely wide open for philosophy. And in some sense, Wittgenstein answered this, or tried to answer this question by saying, let's patch English into a logical language so we can do philosophical statements that are true and false in it. And this is what he expresses in the Tractatus. And then over the course of his life, he comes to the conclusion that he doesn't see a way to ground meaning in a grammatical language. And for his understanding, language is quite similar to what later on Chomsky and others thought of language, that it has to be discrete and made out of features, objects that have only very few properties at a time. So it's very low dimensional locally. And of course, this is not a necessary condition for a general representational language. If you want to build a representational language, of course, you can have objects that have millions of properties if you want, right? And if you want to represent the world in a neural network, then you need representations where individual features can have thousands of sub-features that determine them when you are trying to ground them perceptually. And this is something that is reflected in the way in which we understand the brain to work when we look at the connectivity between individual neurons, for instance, even though it's not a one-to-one mapping.
For our listeners who aren't computer scientists, I found this analogy between programming and Legos very fascinating. But just to make it clear, I'm curious what the analog of the Lego, the building block, is for the programmer. And then just another question. You mentioned a serious interest in vision and spatial representation. I'm curious what it was that you were first programming and then how it transitioned into artificial intelligence.
What I was first programming was very simple things. So for instance, one of the ideas that I had that what to implement is the dice playing game. So where you have to guess the number of dice that somebody else has rolled, or you're trying to get certain combinations of dice and try to beat the others in the score that you get for them. And so I took the rules of the existing games and translated them into a computer program that would evaluate those rules and then provide the sequence of causal actions that are necessary to turn this into a game. And then, for instance, to automate the other players. So I could play against the other players. And then the game would at once be the one that evaluates the performance of the other players, but also produce the causal structure of the game. And by building toy problems like this, I got deeper intuitions about how programming actually works and how it translates your ideas of causal models, of causal reality, into code that is enacting these causal models. And in some sense, programming code is causal models. And the building blocks of programming code are the commands, the computer commands, or the operators in which you express your programs. And what's interesting is that the programming language do not differ in what they can do. They only, because they all let the computer do exactly the same things. They differ in how they allow you to think about what the computer should do. So they provide different levels and kinds of abstractions to ultimately make the computer go through a sequence of steps that manipulate bits at the lowest level. And at the lowest level, there are automata in the CPU, and you can have different sets of automata that produce the same thing. And it's something that already was known to Wittgenstein, who already knew, as is, for instance, explained in the introduction that Russell made to the Tractatus, that you only need the NAND operator, the not AND operator, to build the entire logic. Right. And there are different ways to build the entire logic, but to get to this notion that later was known as Turing completeness, you can have many, many variants of such building blocks that allow you to eventually build anything that you want. So it's relatively simple to get such a set of building blocks. And this Turing universality was something that that Wittgenstein was already aware of, and Turing was his pupil. But Wittgenstein, I think, did not see it as significant enough to spell it out. But I think it's one of the big philosophical insights of the last century. The first philosophical insight of the last century that is really significant in my view is, or one of the biggest ones, is Gödel's insight that the languages of mathematics that have stateless truths, that have stateless computation, are leading into contradictions. There are certain things that you can specify in these languages, but that cannot be implemented. And this is ultimately what Gödel's proof is about, that in these stateless languages there's always sets of statements that you can express, but they cannot be translated into any constructive enactment. And the solution, I think, to this is to discard these languages and go to languages where your semantics is identical to the implementation. And these are computational languages. And this is the first result, that basically the representational languages of mathematics are allowing too much. They are allowing to construct things that are leading into contradictions that cannot be implemented and so on. Versus the computational languages can do all the things that before worked in mathematics, but they can only do the stuff that can actually be implemented, for instance, can exist in a physical universe as we understand it. And the other one is this universality, that all these computational languages ultimately are the same language, that they can all express the same thing. And that's philosophically very significant because it allows us now to generalize the way in which we build models about reality and realize that all the models they are building, that we can possibly build, including all our mental representations, the echoes that we make of reality, the perceptions that we have, the stuff that we can talk to, that we can refer to, are in this domain. And that's quite significant. So to answer your question from the beginning, the reason why I'm interested in computer science is because I believe that it provides a foundation, a representational foundation, ultimately also an epistemological foundation to make sense of reality. And it has left mainstream philosophy in a way in the dust, and mainstream philosophy is unaware of that. And as a result, it seems to me, as now an outsider to philosophy, that it's mostly dealing with problems that other philosophers have, but not in the same sense as Kant. It's not a provider of insights for the everyday working man, right? There was a time when philosophers were trying to produce insights that could be used outside of philosophy, and I don't see this very much in today's philosophy. Today's philosophy is mostly serving other philosophers.
Does this universality you were talking about a few minutes ago, the second great insight, does it connect also to questions of physical multiple realizability?
The idea of multiple realizability has to do with the fact that we can make models of things that are stable causal patterns, even if the substrate changes in particular ways. Right? So, for instance, you can let the same program run on different computers with different architectures as long as there are certain specifications met that allow the software to run. And analogously, you could say that observe that your mind is stable even if you disturb the brain to some degree. Right? So you can kill a number of neurons and your mind is going to entrain new ones. You can change the neural chemistry within certain parameters or the temperature of your brain. And so the physical makeup of the substrate is changing, but the function that is enacted by the substrate at a certain level of abstraction, at a certain coarse graining, remains the same.
Right.
And this is, of course, a source of big confusion. Are these coarse-grained patterns real or not? Mm-hmm. Right, and or do they produce downward causation and so on? And of course, when we are talking about these models of reality, we are always talking about models. And I think emergence or supervenience are fundamentally relationships between different descriptions. So you have a description at the level of, say, activations of cells and a description at the level of mental representations. But you can change many of the cells and many of the activations of the cell, and yet functionally having the representations the same, having the function that is implemented by them.
Because the representation supervenes on the cells?
Yes. Mm-hmm. But it's not necessarily the same thing as different programming languages express the same thing. So this universality is a subtly different property. It describes the fact that ultimately what computers are doing is that they describe causal structure via state transitions. And you can group these state transitions and build relationships to them in different ways. So you can project them into different description languages, but the causal pattern can be the same. And so this universality says that all these description languages, once they allow you to describe one of those computers, one of those systems, can be used to describe all the others. So for instance, the Church-Turing thesis, it's a thesis, it's not a proof, so it's a conjecture, but it says that whenever you have a machine, like a computer that can enact Java, you can use this Java programming language to simulate another computer that runs C, for instance, and vice versa. And you can implement all of these computers on a Turing machine and vice versa. Of course, the graphics are going to suck on the Turing machine.
Yeah. So getting back, though, to your story and toward talking a bit more about artificial intelligence, when did that become part of your work and interests? Because it started with dice. That we're not at artificial intelligence yet.
So when once I realized that I can construct anything that I want, the question is, what is it that you want to build? What do you want to put behind the screen? And the obvious answer is an entire universe full of minds that we can actually talk to.
A simulation.
Yeah, but
maybe that'll come later in the conversation.
There's also this question: is this what we are in, a simulation? So when I look at the world, do I perceive more than a screen, some surface some kind of systemic boundary that I use to make my models over which I project my model of reality. And so to me, in some sense, reality is not different from a screen. That means there is a structure behind the screen, and I cannot know what structure it is. The only thing I know is I can describe it via state transitions, and it produces regular patterns. So the universe is some kind of pattern generator. And because all the pattern generators appear to be in that class, we cannot construct any others. It follows that we can build a thing that produces the same patterns if we have a system with sufficient resources.
Well, I'd like to come back to the simulation hypothesis, but for now, are you saying that as soon as you became interested in artificial intelligence, it was an interest in generating these simulations, or you had more modest aspirations at the beginning?
I was never very modest. I don't know how that works. I also suspect that a lot of the humility that people have is either meekness or it's an act. It's. I also don't think that immodesty is good in any way, but I was more ignorant than immodest. I was just not seeing the difficulty. It was an interesting question. What is the most interesting question that I can work on? And the most interesting question I can work on is, what is reality and what are we? What is the mind? And so this was the most interesting question to me. And I never really stopped asking why, and how. And soon noticed that the books end. Right? You go through the library shelf and you read all the books that are there on this topic, and they don't give you the answer. They don't explain to you how the mind works. And you realize, oh my God, it's an open question. And also, if we actually could construct it, we would understand it. And I don't see a reason why we cannot construct it, except nobody got around to it because we just invented computers and they're still so small, and we are just barely learning how to deal with them and to write programs on them that can learn and make sense of reality.
When you say that you're interested in the mind, what do you have in mind? You're very interested in consciousness, or you're interested in the relationship between the brain and experience?
In some sense, it was a journey. So the first things that I wanted to understand is what is representation? How does representation work? And computer science gives strong intuitions on what a representation is. It's a causal pattern that is implemented on an arbitrary substrate that is representing the dynamics of a domain and allows you to build a system that controls these dynamics, interacts with them. And so learning would be the building of such representations that allow you to get better at dealing with the reality around you. So with the pattern around you, organize in such a way that you can make predictions of what the outcomes of your actions are going to be, and then select action paths in them. And so also decision making seems to be clear. And we can understand motivation from the perspective of control theory and cybernetics. So we are a system that has hundreds of different needs. Many of them are physiological, a dozen of them maybe are social, maybe a handful of them are cognitive. And then we balance all those needs in a homeostatic control system that produces urges to go in a certain direction. And then for a long time, the largest question seemed to be emotion to me. How is it possible that a system feels anything? And the answer that I came up with, and I wrote my PhD largely about this and built models about this together with many students, was that emotions are configurations of cognition. So they're not parameters, but there are ways in which the system works based on how the environment and the assessment of the environment happens. And as a result, we have an unconditional reaction to that reconfiguration. And the emotion is what this change of what you are and how you relate to yourself and to the world looks from the inside when you classify it. And so this question seemed to be answerable. Of course, then you have the more details, you have the space of affects, and you can try to analyze this and use this as a framework to start to analyze human psychology and map this on existing frameworks in psychology and see what that psychologists have discovered many of these things before, and organize it into meaningful framework. Then there's also object-directed emotions like jealousy or pride and so on, where there is something interesting to be understood about how an individual needs to conceptualize itself with respect to environment, what kind of needs it needs to have to be able to have experience violations or anticipations of satisfaction of those needs, and then experience those as emotions, right? And then now I think the remaining important open question is consciousness. This seems to be the main question. What actually is consciousness and how can we implement it? And it's really interesting that there is a very large subset of philosophers and even neuroscientists and so on who don't think that we can possibly understand what consciousness is, that it's always going to be a mystery, or it's something that is fundamentally supernatural and will be outside of the pursuit of science. Even if you are a scientist, you're not allowed to say that out loud.
Yeah, I think a lot of very famous neuroscientists, psychologists, and philosophers think that. I mean, Steven Pinker is the main name that comes to mind as somebody who has this Mysterian position. But
the Mysterianist position, I think, was originally coined by Colin McGinn, but also Chomsky is a Mysterianist. And I think in a practical...
Is he?
Yeah.
Interesting.
Yeah, I think practically Mysterianism is the position that something cannot be understood if it cannot be understood by Noam Chomsky.
No, Noam Chomsky, and when I spoke with him on the show a long time ago, one of the interesting things that he said was the biggest mistake philosophers ever made was to treat everything above the neck as different from everything below it. And that statement, because we don't have any in principle difficulties with understanding the way that a human knee works or the heart works, something like that, it led me to believe that he felt consciousness was something that could in principle be understood. We just had to take a very physicalist attitude toward it.
How would that work?
I don't know. I mean, that's what the NCC program is, but some people don't think that that's very successful.
The name of the NCC program, the neural correlates of consciousness, not in, right, it doesn't say the neural causes of consciousness. To have a causal model of consciousness, that is, of course, the aspiration. And one of the difficulty of half of the theories that are advanced in philosophy or in adjacent fields to explain consciousness do not have any causal structure. Right? So, for instance, I don't see how Penrose orchestrated collapse is actually leading to the phenomenology of consciousness and how that would be related.
For our listeners who don't know that theory, what is it?
Maybe it was not a good idea to open this particular bag of worms, but Roger Penrose is famous for having made his contributions to understanding black holes. He got a Nobel Prize for this in 1967. And he's also written a very beautiful popular science book called Road to Reality that is explaining many of the main concepts of mainstream physics in beautiful level of detail. So it's basically a book that you can, as an intelligent person, read without knowing a lot of mathematics and theories of physics. And it's not that large. It's 1,200 pages, like Lord of the Rings or so. And it really walks you through the main ideas, main intuitions of physics. And like Feynman, it doesn't let you do exercises, so maybe it doesn't stick that much, but you get very good intuitions about what physicists are talking about. And he also has made some contributions called twisters to understanding of quantum mechanics that are not that much in widespread use. And then he has developed, often mentioned in conjunction with Stuart Hameroff, a theory that consciousness cannot be understood computationally. And he's written a book, The Emperor's New Mind, that is trying to elucidate the fact that mainstream cognitive science and neuroscience and so on might be barking up the wrong tree, have the wrong ideas on how consciousness works, because ultimately their ideas are all computational. And he takes Gödel to prove that there are limitations to what can be done in formal languages, and that these limitations do not apply to human minds, which is, I think, a very bold conjecture. And a lot of...
there's a lot of philosophy about this.
Yes, a lot of analytical philosophers, I think, would talk back to him, and for some reason he doesn't feel compelled to listen to the counter-arguments. And instead he is arguing, well, I think that current physics is in some sense computational. It basically describes the universe as a state vector, and then a transition function comes along and you get another state vector, right? This is a computational model, regardless of whether it's quantum or not. And so consciousness must happen in the areas that are not in the known physics. And the part of the current formal models of physics that are not well understood are, for instance, in the realm, or especially in the realm of quantum gravity. So maybe it's there. And so Penrose has a theory that I don't actually understand about how or that quantum collapse leads
in
to
nanotubules or
yes,
something.
The nanotubules part is, I think, Hameroff's addition. I don't think that they're actually the same theory, because you don't need extensions to quantum gravity to explain how Hameroff's idea on how computation would work in superconducting microtubulus works. But of course, Hameroff's theory, which is not the same thing as Penrose, even though they're published together, does not rely on extending physics beyond the computable, even though Hameroff says that. But what he basically claims is that superconducting microtubuli are able to perform quantum commutations that are non-local by interacting with each other across cellular boundaries. And I don't have an opinion about this particular theory because I don't understand anesthesiology and cellular anatomy to such a degree that I would be able to judge the probability that Hameroff is correct or incorrect. And I observe that physicists are very skeptical of the notion that high temperature superconductivity could work in biological cells in microtubuli in this way. I also observe that nobody puts large resources in building computers for microtubulus. So basically all the people who are experts in the respective field do not take this theory very seriously. But I have no idea whether that is because he is not onto something or because not. I can only judge the parts that I understand. This is his claims about computation, about how to interpret Gödel, and I'm unconvinced by those parts that I understand, mildly put. But I don't know if this translates to the rest. Maybe there is something like a global microtubulistic mind and Hameroff is able to tune into it using the right anesthetics and substances and medicines, and then has some insights. Who knows?
When I hear quantum gravity invoked, my hackles just raise, because I know that quantum gravitational effects don't manifest until you're down at the Planck scale, and if we could just learn about quantum gravity by investigating the mind or consciousness, that would be very neat.
Yes, there is something interesting involved in this when we zoom out and look at the space of possibilities what consciousness could be. The question is, at which level is it implemented? And at the moment, I think that most people in neuroscience who are willing to make statements about consciousness, and I don't think that's even a majority, most of neuroscience doesn't even look at the phenomenon, would say it's an intercellular phenomenon. Basically, it happens across cells.
Right.
So, for instance, via synaptic excitations and so on that produce activation waves that go through the brain and so on. And somehow in the patterns of these activations, we find the encoding of consciousness. But who knows? Maybe it's a phenomenon that requires cellular mechanisms inside of the cell and works orthogonal to the cellular boundaries, right? It could be that there is some types of molecules across the cells that implement consciousness, and all this activation firing and so on is an additional process that happens. Maybe this whole thing happens at the submolecular level even. Maybe it's a pattern that happens at the level where elementary particles are implemented, or it happens below the level of elementary particles. It's difficult to reason about it and think about it because we don't have scientific models that are talking about structure at these domains. And so we could say it's unscientific to reason about this or think about this, but logically we cannot exclude that there is structure at this level and that the structure could in principle implement consciousness. It just seems to be far less likely given the phenomenology of consciousness that we observe. So from my perspective, what we seem to be observing about consciousness, and I might be wrong, is it's slow. So it seems to be compatible with the speed of sound speed in which our brain roughly operates, and we look about how activation spreads in the brain. And it seems to be relatively coarse and noisy. Mm-hmm. And it seems to depend extremely on the state of my brain, right? So basically, if you squish my brain, my consciousness instantly changes. If I squish anything else in the universe or any other level, then my consciousness doesn't change in the same way.
When you say that it's coarse, is this again going back to the supervenience of mental states?
Oh, I also mean that it's noisy. So it basically feels as if my consciousness does not have an infinite resolution compared to the number of cells or molecules that exist in my brain or the number of synapses. So it appears to me that my consciousness is able to produce the impression of infinite detail in a similar way as a fractal can, but the fidelity of my consciousness is relatively low. So the number of features that I can reliably track, the differences that I can tell between different objects and so on is not that high.
Are there? So I take it you're resolutely not a Mysterian,
No.
right?
So I also don't think that Mysterianism makes a lot of sense, because I believe that whatever the problem is, ultimately you're looking at a sequence of states. And you can always come up with a computational model that explains an arbitrary state sequence. It might be extremely convoluted, it might be wrong, and so on. But it's never the case that we cannot find an explanation. Its difficulty is to find a useful explanation, one that is relevant, one that is practical, and one especially that is truthful in the sense that it actually captures the phenomenology or the features of the thing that we want to describe.
Just to get some philosophical cards out on the table, do you come at this problem open to dualism or panpsychism, or are you more of a physicalist? Or what sort of constrains the possible theories of consciousness that you find compelling?
Basically, I'm open to any kind of theory as long as I get it to work.
Okay.
And difficulty with most of the theories that you listed is that I don't know how to get them to work. And even physicalism, for a lot of people, there seems to be a belief in physical objects or physical substances involved. But is this a necessary belief for understanding the mind? I don't know. For all I know, it's possible that we are always living in a dream. And in some sense, I find myself to be living in a dream, right? That's my experience. The objects that I experience, including the device that makes physical measurements, are objects that I dream. And this dream, the best explanation for the regularity in the dream is that the dream is constructed to track regularities in sensory data. And it's constructed inside of the brain of a primate. Mm-hmm. Right? But this brain of the primate and so on, how do I know about the brain of the primate? Oh, my teacher told me. How does my teacher told me? They learned at university and read it in books and so on, right? But who came up with this idea and based on what, and what were the available alternatives to these ideas? That's ultimately what we need to ask, and basically how leaky is the epistemic chain from the observations over the arguments and conclusions in the theory space to me when my teacher tells me. Mm-hmm. And as a child, I was extremely skeptical about the coherence of that chain, because first of all, I was super nerdy and ignorant and stubborn. And second, I lived in communist Eastern Germany, so per default, everything that my teachers told me was wrong. Mm-hmm. So from my own perspective, also came from an artist family that didn't believe very much in the state propaganda. And I had tons of books in my house, and I realized that many of the people who had written books hundreds of years ago, I had more in common with them than with my teachers. Because they were more rigorous in their thinking, and they actually cared about the thoughts that I had in a way in which my teachers didn't. And so I found very often that, of course, the teachers are giving us models that are tested, that are useful in practice, that have worked in practice. But if I ask them metaphysical questions, they're usually not even interested. And when they give answers, these answers tend to be shallow or wrong. And so if you have theories like physicalism, what does it actually mean? And to me right now, physicalism means that there is a causally closed mechanical layer to reality, and we directly supervene on it. Right? It's it could be that there is a physical universe that is entirely mechanical, and in this physical universe exists a computer that is operated by some nerd, and you exist as a simulacrum in this computer, and the world around you is arbitrary, right? But that means you're not in a physicalist world. For instance, if you lived in Minecraft, even if Minecraft exists on a physical computer, this would not be physicalism, because you would not directly supervening on this mechanical layer. The regularities that you observe are only the result of arbitrary ideas of a programmer, not the result of what's happening in physics at the lowest level, right? So physicalism is this idea we are actually in base reality. And if I think about what's an alternative to physicalism beyond a simulation theory, beyond the idea that there is this causally closed mechanical layer is somewhere else, how does this work? What would it look like if there was no foundation to the world? Or is it just a conspiracy? I just don't know how to think about this. And so I can think about the idea that the universe maybe at the lowest level is some kind of tautology that explains why there is something rather than nothing. And then I see a branching multiverse by applying all possible operators simultaneously and so on. I come to a possible explanation that I am in a branch of this space of all possible realities that would exist as such a mathematical tautology, right? And this ultimately is a physicalist worldview. But it's quite different from what a school teacher would call physicalism, right? And also, to understand physicalism correctly, we still need to accept the fact that what you're looking at is not res extensa in a Cartesian sense, because basically Descartes thought that what we interact here when we touch stuff and we are observing ourselves to be in space and so on is in some sense the physical universe. But of course it's not. It's a game engine generated by your brain. There are no colors or sounds and so on in physics. They only exist in your own mind. So I do have to accept that the dreams at night are not that different from the dreams during the day. Only the dreams during the day are much, much more stable because they're tuned to model sensory data that are kept stable by some pattern generator outside of my mind, which we call the physical universe, right? So in this sense, you could say that I'm a dualist because I accept that there is a representational layer in which I exist as a perceiving being, as a causal structure that is ultimately software, state transitions implemented on a different substrate and ignoring the actual physical dynamics beyond the fact that they can be used for representation. And then there is this physical universe that makes all of these things possible. But I can never visit this physical universe because I'm not conscious in physics. I'm only conscious in my own dream of reality, in my mind, in my representations.
When you say that what constrains your theory choice is whether or not you can get this theory to work, I'm wondering whether you mean, let's just take panpsychism, for example. You're saying that for panpsychism to work means that you can tell a story that you find compelling and explanatory for how it accounts for human consciousness, or you're saying that, and this gets us back to computer science, you don't know how to use panpsychism to program an AGI that is conscious.
So how would you formalize panpsychism? And you actually spell it out. What is the relationship between observables, the structure that realizes the observables, and, for instance, the phenomenology of consciousness that you want to explain? How do they relate to each other? And I find that a lot of panpsychists are unable to spell this out in a way that is satisfying, that basically makes sense, or spell it out in a way that makes it different from, say, computational dysfunctionalism. And maybe take a step back and explain what computational dysfunctionalism means, right? So first of all, functionalism is an epistemological position. Epistemology means our theory on what can we know about reality and how do we get access to what we know. And in functionalism, the idea is that we construct objects based on behavior. So for instance, we construct the idea of a water molecule based on the behavior of a certain aspect of physical reality that is in some sense invariant, right? So we notice that we can split the water molecule. We notice that we can combine many water molecules into a liquid that is water, and we can explain water by being a combination of these molecules at certain temperatures and so on. Right? And so this is all behavior. There is never do we get in contact with the essence of a water molecule, with something that is beyond observable behavior. So everything that we construct as a water molecule is the result of us trying to regularize and abstract all our observations related to that phenomenon, right? And so the idea that it's explainable by this particular singular phenomenon and so on makes sense from the perspective of functionalism, because the water molecule is describing a set of functions that can be that lead to interactions with other changes in other information in the world, right? It would also not make sense from this perspective to say that there is an object in physics that is behaving in every single way like a water molecule, that shares exactly all the properties of a water molecule in every regard, in every possible measurement that can be made, but it's different from a water molecule, right? Because we never got to the idea of a water molecule from something else but behavior that we observe, right? And so there is this idea, the alternative to functionalism would be some kind of essentialism, that there is some hidden essence that yet makes itself known to us in some way beyond behavior. And I don't know how that would work. right? Otherwise, if it's observable behavior, again, it would be a property that we observe that would be translated in some function. And the other one is computationalism, the other aspect, and that's a position about representation. It basically says that we can represent an arbitrary thing or model an arbitrary thing using state transitions. And to say that there are things that cannot be modeled by state transitions doesn't sound absurd, but it's a very bold statement, because it means that physicists are missing something, or everybody is missing something who is making models. So what should that be? And so I think that this position of computationalist functionalism is a relatively basic idea about how representation works and how epistemology works, how objects are constructed and knowledge is constructed over those objects. And so when we are trying to attack this position and somebody says, I'm going to build a non-functionalist theory of consciousness, I am very curious. And for instance, Giulio Tononi is trying to do this in IIT. But IIT is trying to describe consciousness using information theoretical regularities, which means functions. And this is difficult, right? Because at which point is he able to introduce something in his theory that is not functionalist, and yet is somehow a notion that you can work with as a philosopher or as a scientist? And so it seems to me this belief in essences that do not reveal themselves, yet we know about them, seems to be a superstition. It seems to build on some kind of intuition that I construct in my mind, but when I closely examine the intuition, I notice that it's empty, that there is no way in which I can build something that is realizing some kind of formal difference between that intuition and another system. So when somebody is saying, a panpsychist, and they say that, for instance, consciousness is an aspect of matter that is distributed in the universe and it's everywhere in the universe, right? You would probably, if you ask this person, does this mean that everything in the universe is equally conscious? It's probably not what you want to get out of this, right? There seems to be some kind of difference in the phenomenology between a person that is anesthetized and a person that is not, or a person that is dead and a person that is not, or the empty space between people. Right? So even if there is something going on in the empty space between people, it's to some degree different than what's happening inside of your organism, especially your brain, with respect to consciousness. So you have to explain this somehow, right? So, but if you have a form of panpsychism where you say, okay, but it depends on the structural properties of the matter, and only when you have a certain density of certain structural properties and so on, then you could say that what is the seed of software in the world? And it's everywhere in the world, but it's implemented to a different degree depending on the functional structure of things that are enacting it, right? And so the more you are looking into this, as soon as you then identify criteria for when the structure exists, like control systems, energy consumption, and so on, stability of a substrate, and so on, the more you add to this, the more your panpsychist theory turns into box standard functionalism, right? And unless you make a radical step and say, all your observations have actually nothing to do with consciousness. The fact that you are behaving differently when you get anesthetized or when your brain gets destroyed is completely irrelevant to consciousness, because consciousness is something that's much more fundamental than this. Right? But then we are not talking about the same phenomenon anymore. We are talking about your idea of something fundamental that can no longer be mapped into what I observe and what I try to make sense of.
Are you looking toward philosophers or neuroscientists or computer scientists or some other class of researcher to make the next big breakthroughs in consciousness, or is it all three of them? Because, I mean, you don't think philosophers are doing good work on representation, for instance. So I'm
sure that philosophers are doing good work on representation. There are extremely smart philosophers who do analytic philosophy of the highest regard. It's just when you look at the mainstream of philosophy as a field, and you look at what goes into the canon of philosophy at the moment, I feel that even Gödel has not been digested. And so when you have a person that is educated in philosophy and has read the mainstream literature and has a degree in philosophy and so on, and you ask them to summarize Gödel's proof, they are probably not adequate compared to a computer scientist who has gotten a good education in formal logic. And I'm somewhat flabbergasted by this, that you have summaries of Gödel's proof, even books about it, that still treat it as some kind of sculpture in the Museum of Mathematics that is somehow very important and very grave, but it does not actually change the way in which we think about reality. And it should, if we understand it.
Who, though, is it that you're looking to for inspiration or further developing theories of consciousness?
Well, there is a very large number of individuals in many fields that do this. So it's not, I don't think that there are fields where there is no single smart generalist thinker. But I think that at the moment, people that I find very inspiring, for instance, Mike Levin.
I saw you spoke with him recently.
Yes, he is somebody who is saying a version of what you attributed to Chomsky, in the sense that there is a big similarity between how development works in organism and how representation and organization works within a mind. And maybe this is mostly a difference of timescale and not so much just a similarity that is superficial. So maybe these principles of self-organization that we observe in organisms are crucial for understanding the self-organization in the mind. It could also be that when we zoom out very far, that we find many of these principles reflected in the organization of societies and organizations. Of course, I don't think it makes sense to claim that societies are conscious in the way in which people are conscious. For a similar reason, I don't think it makes sense to assume a priori that organisms by themselves are conscious in the same way as nervous systems produce consciousness, if they do. Right? In neuroscience, I think the number of people who work on this question of consciousness to some degree, for instance, one of the most famous teams is run by Stanislav Dehaene. And there are many people who are making important contributions in this field, like Antonio Damasio, Michael Graciano has had an influential set of ideas in this space.
About attention?
Yes, this attention schema theory.
Mm-hmm.
But on the other hand, you have philosophers like Thomas Metzinger and so on, David Chalmers, who are very smart, who think deeply about these questions. But ultimately, I think to make progress, we need to move to testable theories. And most fields do not have very good methodological frameworks right now to no fault of their own. So one of the reasons why psychology, ironically, has stopped studying the psyche is because psychology understands in some sense that the psyche is a system with so many variables that you will not get a model where you can test your theories in a lab using the existing statistical methods. Mm-hmm. So if you have not testable theories, it's not science. And so psychology makes the decision to be a science instead of being a praxis, or a literature form or something like this. Or in some sense, I think that it has excluded philosophy from its own pursuit, which maybe it shouldn't. So if you, for instance, look at Piaget, I don't think that Piaget is so much unscientific in philosophy or William James in psychology. It's that they are interdisciplinary between psychology as a science and the philosophy of mind that is necessary to understand human development, human representation, and so on. So in a way, I think these fields would have to be bolder and do more philosophy. And philosophy might also have to be bolder to go back into actually describing phenomena that we observe and cannot yet explain, rather than writing about what other philosophers said about it.
Toward connecting consciousness, which we've been talking about, and then artificial intelligence, maybe first we just ought to get on the table a definition of intelligence, forgetting the artificial part. But how do you think about what intelligence is?
At the moment, I think of intelligence as the ability to make models.
Okay.
Right, so you could say it's what you use when you don't know what to do. Intelligence is not just deploying a skill or having a skill, right? This is completely unrelated to intelligence, because I would argue that a chess computer that is merely enacting a predefined algorithm is by itself not intelligent, even if it's performing a task for which people would need to be intelligent to perform it. But this ability to make a new model, usually in the service of control, is intelligence. And what I like about this approach to defining it is that it doesn't say anything about performance or success. I think we observe that some people can be highly intelligent without being wise or smart.
Right.
And so wisdom or smarts are slightly different from intelligence. They have to do something with goal, rationality, and so on. But some people basically compensate their regulation deficits or their lack of wisdom by being more intelligent, by making more models. And these models can be extremely detailed, and they can be very, very clever and so on, without actually being helpful. Right? So intelligence is a certain faculty that you deploy in a certain area of the cognitive function. It's not the same thing as agency. And so, for instance, when you are a CEO of a company, what you ought to maximize is probably not your intelligence, your ability to make models, but your ability to actually solve problems in the pursuit of the goals that you have. And so you should deploy intelligence where it's necessary, but you should also not spend all the time solving problems just because problems exist. Right? And many highly intelligent people really do enjoy specializing on that kind of pursuit. Right? It means that they play an important role in an organization like a company or in a research team, but the ability to make models is by itself not the most important thing when you want to be successful in the universe. So I would make a difference between intelligence and agency, where agency is the ability to control the future.
So intelligence in its relationship to making models is very closely associated with a capacity to solve problems, but it's not solving those problems because that requires deploying the intelligence.
Yes, it requires action, and it also requires making the right models, evaluating them in a particular way, and so on. But intelligence is, in some sense, you could say, an IQ test. What we measure is the ability of people to solve puzzles.
How does artificial intelligence differ from just intelligence?
Artificial intelligence is, in some sense, a slogan, and it is a field that was started by Marvin Minsky and John McCarthy and a few others in recognition that the computers are offering a new paradigm. It has happened in the 1950s. And Marvin Minsky positioned artificial intelligence as an alternative and extension to cybernetics. Many of the original founders of the field and people who joined it were cyberneticians. And cybernetics was the idea that we can describe our ability to make models and ultimately our minds using control theory, using feedback loops and so on. And computation is generalizing this in a way. It goes away from this continuous notion of dynamics that you control to automata that you can, from the ground up, construct to do anything, describe anything, including those feedback systems and these control systems. And you could say that initially there was some kind of rivalry between cybernetics approaches and the computer science approaches, the AI approaches, because classical AI is mostly looking at symbolic systems, at discrete systems, at ways how to combine those operators to build the structures that you want, instead of going straight for the control thing. And so there is the question, what is more fundamental? Is at the fundamental level, what you should be starting with, is this the continuous control stuff, the dynamical systems, or is it the world of the automata? And we can show that they are in some sense equivalent. You can build automata from control structure, and arguably that's what we are doing when we are building transistors. We just make them so big that the control structure is stable enough to produce these multi-stable transistors. And then on top of this, we build discrete logic that is allowing us to do arithmetic and then linear algebra. And then we build neural networks that are continuous again. And then we train the neural networks to speak discrete languages again, and so on. Right? So you can build layer on layer, and you alternate between the discrete logical stuff and the continuous control stuff. Right? That is more geometric. But Minsky opposed cybernetics in a way. And I think that because he thought that this computational automata approach is more fundamental, he actively opposed both neural networks and cybernetics and led to a rift in computer science. And I think this was, with hindsight, not a very good rift, because it led to a delay of connecting ideas across fields.
Now I'm wondering, one of the things that you wanted to speak about today that I'm very curious to hear about is the current wave of AI and what it is and where it's heading.
So it's difficult to say what the current wave of AI actually is, right? Because there are many ways to look at it. Is it deep learning, or is it the transformer, or is it the LLM, right? So with different degrees of specificity. But you could say that in some sense, the deep learning revolution started in the 2000s, when people discovered that it's possible to train neural networks with almost arbitrary numbers of layers and almost arbitrary numbers of parameters. and you just need to use more data and more compute to do that. And then people came up with some algorithms that made this efficient. So it was actually feasible for large amount of data, like training on the entire internet or training on hundreds of millions of pictures. And the first algorithm that was discovered in this regard was the transformer. And the transformer was this breakthrough after the deep learning revolution that discovered that we can basically make selections over what we should be learning, basically make statistics over what we need to make the statistics over. That was one of the aspects of the transformer, that you basically train your neural network what to pay attention in the previous layer to. So you don't look at everything at the same time. You learn in the present context what things matter most. And the other aspect of the transformer that was super important was to make this parallelizable. So you can run this on a distributed GPU farm and make it feasible to do it fast. Because if you want to make it faster, you can distribute it on more GPUs instead of just waiting for one to compute longer. Right? And so the trick to training on the entire internet, all the text in the internet, is to parallelize this as well. And this is what's driving most of the present progress. And most people agree that this is not the answer. But it is an important part of the answer. And the scaling hypothesis basically is the idea that the present classes of algorithms, together with twists and improvements and so on, and some important insights that we're going to make along the way, are going to be sufficient to get us to artificial general intelligence. AGI is a notion that came up after the first AI winter in a way, because
the first AI what?
AI winter. So what happened is that in the 50s, when Minsky came up with this idea of teaching computers how to think, he thought this is going to be it's not going to take us very long. We're probably going to be able to figure out what this is, the generalization of thought and learning, and implement this in a computer, and then we just need to wait for the computers to be big enough and everything will fall into place. And at some point he said it's going to take between 400 and 400 years, who knows.
Oh, wow.
So at this point he already took a step back. And then in the 1970s, 1972, a team in Edinburgh was trying to get new funding for a lab that was combining ideas and ambitions from robotics and learning and AI into an AI project. And the Royal Society put an outsider on this to study this and to see whether this is basically a generalist. And this was Sir Lighthill. Lighthill was nominated an atmospheric scientist, but he was a polymath and very smart. And he didn't get along with Dennis Mitchell, and so he basically he recommended in a review that was leaked that this was not to be funded. And his argument was mainly, it makes sense to build robots. It also makes sense to build models of the human brain to be more brain-like, but to model, for instance, neuron functioning and so on. But it doesn't make sense to try to build robots that are human-like or that basically have a human-like mind. And they try the original AI researchers and John McCarthy and others tried to explain this is not the point. It's not about the robots. It's about building minds. It's about building systems that can learn, generalize, abstract, and so on. And we think that this is possible, and it doesn't necessarily require that we do exactly what biological brains are doing or try to mimic this or try to understand neurons or neurochemistry, but it requires that we understand what the brain is doing, what it's computing, the mathematical principle behind it. And I think there is a big cultural opposition in our society. Our society is, and I think this might be a unique feature of Western Christian and post-Christian society, dualist. In a sense, the world that we are in is some kind of simulation, some kind of Minecraft. And our souls are sitting outside of this world. The true mind is not of this world. It's something supernatural that is in the layer outside and above natural reality, natural mechanical physics, and somehow talks to it and interacts with it. And the idea that we could be NPCs, that we are just patterns within the physical world, patterns within Minecraft, is blasphemous. It's an insult to how we perceive ourselves. And I think this is part behind this opposition. And the Lighthill report led to a canceling of funding for most AI research.
Oh, wow.
And to this, what was called the AI winter. And it basically happened, I was born in 1973, so I was born into the first AI winter. And in the 1980s, we got progress in rule-based system and logic, and then came expert systems and so on. And expert systems famously didn't scale into AI. And in a way, it's only deep learning that is solving this Wittgensteinian puzzle. How is it possible to ground language in reality? How is it possible for a system to build representations that mean something? And regardless of how optimistic we are about the mind-like structure or the potential of LLMs, I think it's somewhat clear that they are able to answer the question of what does it mean to mean something. Because meaning is the reference to a model, right? To an integrated model of reality. And the interesting thing is that the LLM is able to build an integrated model of the entirety of the universe.
What do you mean by that?
So when we are talking about meaning, what we don't refer to something outside of ourselves. And there are these reference theories of truth in some areas of philosophy that I don't know how to get to work, because I don't know how to make an arrow outside of my language into a reality, right? And this is something that mathematicians have discovered and talked about for a long time, Lip's theorem and so on. It's not possible for a system of representation to prefer outside of itself. It's also something that Gödel recognized. So his way to talk about mathematics would require to talk about the definition of the language that he uses for his mathematics, for his logic, and this definition would be outside, right? So the way to do this is you need to rebuild the language inside of itself, to build an emulator. And it's brilliant that he discovered this. Gödel built the first emulator for making his proof, where he is emulating his logical language inside of the logical language, and thereby is able to make references to the inside. And I believe the same thing is true for ourselves. To be in a mental state doesn't mean that we know what this means to be in that mental state, or even that we are in that mental state. We have to make a model of us being in that mental state, right? So we have to build a simulation of ourselves inside of ourselves. And the simulation is not functionally equivalent, right? Of course, it's a simplification, abstraction of certain features of how we work. But if we had enough capacity, we could possibly get to the point where we make a model of how we actually work. And there are some people which argue if we could make a model of how we work, we would not be complicated enough to do that. That would be a paradox. But I don't think that's the case. Right? It's only a matter of how much memory you have and how much redundancy you have in the system, because, of course, you do not want to explain every single of your memories. You want to explain how you can form memories and experience them as recalls of a past situation and so on, and use them in the context of all your mental operations. And for that, you don't need to explain all these details. You only need to create a few very specific memories, right, to explain all this functionality. In the same way, it should be possible to train an LLM on papers about how LLMs are written until the LLM is able to not only explain to a human how an LLM works, but also write the code for making an LLM, and even possibly modify it. And so to get back to this question, what are the limitations and possibilities of the current technology? The short answer is nobody really knows. Some people have strong ideas about it, right? There's people which make strong bets on it, that just by making more training to get models that are more predictive of text, we're able to get these models to also reason better and ultimately to turn language into a self-play, where this thing can reason with itself and derive the Riemann conjecture or something like that, that is not in the training data. Mm-hmm. And there are other people who say maybe this is going to plateau and you need to look from a completely different angle to get to an intelligence that is self-improving and that learns as efficiently as us. Both sides, I think, agree in a sense that LLMs are not the way in which the mind works, the human mind works, right? It's only something that happens to work very well, to extract structure from textual data.
This was another thing that Chomsky really stressed when we spoke, was that he said that you will not learn about the human mind or how human language works by studying LLMs.
So I'm not so sure about the latter. I think that language ultimately is the solution to a particular problem. The problem is how to translate mental representations, which are some kind of fuzzy hierarchical hypergraph, in such a way that another human being is able to build an equivalent representation in their mind. And to make that happen, we need to constrain the mental representations into a protocol that is learnable. and also interpretable with very limited resources. And our brain has very limited resources because it's not able to perform arbitrary operations in a stable manner. There are certain problems that we cannot solve in a parallelizable fashion. So for instance, when we parse language, it makes sense to limit the stack size that we need to do that. If we, right, in a computer, you can make a stack that is millions of bytes deep, and that's not a big problem. But in a human mind, if you go more on 4 levels of indirection, you lose track of what's happening because you can only keep so many balls in the air. So in some sense, human languages are constrained to mapping mental representations into strings of discrete symbols that need to be so few that they are learnable, and they need to be parsable, so interpretable and constructible, these strings, with the stack depths of, say, 4 or so, give or take. And this defines a space of possible solutions. And I suspect that human languages are roughly congruent with that space in a way. Right? Solutions that are given by the constraints of that space. And if we want to discover the criteria that are common to all human languages, we can probably evaluate commonalities in the tokens of LLMs that have learned multiple languages.
Yes, what Chomsky was stressing was that the fact that LLMs can learn quote-unquote impossible languages that humans cannot learn is just a proof that they work in such a radically different way from our own language learning faculties that we're just too dissimilar for us to use LLMs to learn about human language.
I don't think that one follows from the other. The premise is, of course, true. The LLM training works very differently from the way in which we learn language. We could not learn language in the same way as an LLM does. And on the other hand, the LLM is not just more inefficient, because we basically need to give it massive amounts of data before it's able to learn a language. But once we train an LLM to do that, we can also give it a dictionary of a new language that was not in the training data and a grammar. And it's able to internalize this and then instantly use that language at the level of a human speaker. Right. And that's something that a human speaker couldn't do, because a human speaker would need some more practice, arguably, to memorize all those words and extrapolate the grammar and understand it. Right? So there is stuff that's falling in place in the LLM because it has vastly more resources and a very much more powerful way to represent causal structure than the human brain does. That is not available to the human brain. So the LLM is both more and less efficient than the human brain is. But the LLM is building a representational structure. And this representational structure is aligned to language use. And it would be surprising if there are not some similarities in the structure that the LLM is discovering and in the structure that the brain is discovering at a certain level of coarse graining, at a certain level of abstraction. And we find this with vision, for instance. When we are training an end-to-end system on images to be able to reproduce images, we find that the hierarchy of this vision model is quite similar to the hierarchy of the visual models in the human brain. So we find equivalence of a lot of the brain areas basically in the layers of the neural network, despite the neural network not working one-to-one comparable to neurons. But this is something that Chris Olah calls the universality hypothesis, which is basically if you have a general enough representational substrate and you train it sufficiently long on a given problem, then different modeling approaches, in some sense, are going to lead to a similar model structure.
Given this model generating definition or understanding of intelligence, before we move on to some of the possibilities and limitations that you alluded to earlier, I'm curious how you think that some of the major technologies in the current AI wave, such as ChatGPT, how well they or how much they qualify as intelligent.
It seems that the models are able to be intelligent at a certain time scale and certain contexts where humans are not intelligent and others where they are. And one of the issues with the present approaches is that the systems that we deploy they make basically, they hallucinate And it's also arguably a property of our human mind that we hallucinate. I suspect that I have a basically hallucination ability in my brain that is always on. But I have a critic on the other side that is cutting down these hallucinations and, for instance, test them against sensory data. And when the hallucinations of my visual system are not predicting my visual data very well, they basically get pruned, and only those that are predictive are continued. But when I dissociate from my sensory inputs, for instance at night when I sleep, I don't have sensory input anymore, but this visual modeling area is still active. It's going to produce continuations of its present state, and these play out as dreams. Right? So they're basically free-running hallucinations. And in many ways, you could argue that what the LLM is producing when it just continues text, it does something very similar. And people find this very problematic because when you train a model on the internet, and you don't train it on being always factually correct, but you train it on producing text like on the internet, it can give you Wikipedia articles about non-existing people. Right? And so that's a big problem when you are trying to use it in a context where you try to replace Wikipedia with your LLM instead of getting ideas for writing a new Wikipedia article for a new non-existing topic. Right? And so maybe this is a task where we have to communicate clearly that the LLM is actually not comparable to a human brain in its ability to reason and give you truthful information, but it's somewhat comparable to a human brain in the ability to come up with new ideas. But it cannot test these ideas because it is doing this mostly in a one-shot form, in the same way as you are producing one association and without rehearsing this association, spelling it out as text. Right? Normally, when you are trying to solve a problem or develop a philosophical idea, you're not going to use that intuition as your final output. You're going to go back and criticize this intuition, look for all the loopholes that you've seen and so on, and prune it and get it down to something that works. And it's an iterative process that doesn't go once, but it's a back and forth. And so this is missing in these present approaches. And a lot of people in the AI companies which work on building that. And in the meantime, what they are doing is they fine-tune these models to be less creative. So they prune their output preemptively by training them on stuff that is basically proven or reliable, and they penalize them for producing stuff that looks unreliable. And as a result, they tend to produce more stuff that looks more reliable and more authoritative, which arguably I think is even more problematic. Because now it looks as if it was authoritative, but it is now basically just emulating a person who understands.
So you really can't tell if it's a Wikipedia article, a fake Wikipedia article.
Yeah, or an opinion piece by a journalist who just has an opinion and is only socially motivated. Right? So it's basically, it's now, some people disparage social sciences as the soft sciences because you get away with saying stuff that doesn't need to replicate, because the criteria for whether this is publishable are depending on your community, on the social acclaim that you get by publishing it. Right? So there is no hard and fast analytical criterion or empirical criterion that determines whether what you are saying is true or not. It's entirely a social criterion. And in a way, the LLM is, when you don't mitigate it, operating like this. And if you make it sound more authoritative, it's infuriating to try to get this thing to be creative again, because now it is both wrong and stubborn in insisting on not being creative. Right? So that for me is a big issue, especially when you, for instance, take an LLM and you ask it an interesting philosophical question that philosophers don't have a consensus answer for. And that thing is trying to emulate a non-existing consensus.
Something that I found refreshing at the outset of your response was that you said it is intelligent in some contexts, but not intelligent in others. And what I appreciate about that is I think people have a pretty major anthropocentric bias, and we don't want to label computers or non-humans as intelligent. So, for instance, I mean, there might once have been this idea that if a computer has to be intelligent if it can beat a human at chess, but as soon as the computer beats the human at chess, we shift the goalposts. So I just appreciate that you don't see it that way. But the next thing that I'm wondering about is whether or not there is a simple answer to what has to be done to get the current generation of AI from being intelligent in certain contexts to being intelligent in a much broader context, so that they're generally intelligent.
In some sense, it's ironic that people thought that logic is going to be easy, but common sense is going to be hard. And it turns out that the LLM, in some sense, is solving the problem of common sense, but it has difficulty with logic. On the other hand, these systems are getting better. Right now, we have systems that are able to solve tasks at the level of Math Olympics. But I still find that in many contexts, when I use the LLM in the areas where I'm actually competent, it does not necessarily reach my level of competence. And so there is this question, is the LLM that is imitating people in all dimensions going to surpass people by imitating them on more dimensions that an individual can be competent at? Right? So in areas where I have no competence, the LLM is usually better than me already. Right? And that is really interesting, especially, for instance, for people who cannot write.
Right.
Or people who are not able to understand complicated text. The LLM might not be good at understanding complicated text as good as a lawyer who is competent in his field, or as a scientist, or as a philosopher, but it's going to be much better than a person who doesn't understand how to read that kind of text or to write it.
This is a really nice point.
Yeah, but it also elucidates some of the danger, right? Because you might come to rely on a system that is giving you some kind of fake competence, that looks as if it was competent, but you don't, because you are unable to fully understand its limitations, because you're not proficient yourself, you don't really understand where it doesn't work anymore. And for me, a good benchmark is still writing programming code in an area that you understand and think about. Is this thing able to outperform you in writing novel algorithms, for instance? And how many mistakes does it make, and how logical are these mistakes? Of course, it's very good at writing boilerplate and solving problems that have been discussed on Stack Overflow, but I still find that coherently solving complicated problems and expressing them as code is still something that even the leading LLMs that are publicly available cannot solve at a human level. But if you are such a programmer who can do that, then that thing can make you more productive.
Is there a known path, though, for getting the LLMs to be able to write code that is more competent than yours in an area in which you're already pretty competent?
That's an open question.
Okay.
But it would be surprising if there was no path. Right? So, of course, there are people who are making bets on that. And,
yeah, what are some of the options?
We work in teams on this question. And so how can we make more long-form reasoning? One way of doing that would be to try to turn programming into a self-play task. For instance, AI systems get much better than people at playing Go just by playing against themselves. And because they are so fast, and if you give them enough resources, they're able to outperform thousands of years of human Go play within a day. Right? So if you say that a human Go player is, of course, not learning the entire game of Go by themselves if they're at the expert level, but they are drawing on the experience of Go players in the past. And a similar thing is for grandmasters in chess. Use the insights of chess players before them to get better at chess. This is all not necessary for the LLM, because not for the LLM, but for the AI training system, because it's able to surpass that performance of human games by playing against itself and finding regularities in these games. And so there is this question, how can we turn language and logic and so on into self-play? And that would require that we are grounding the logic that we're using to describe a world onto first principles, and understand how we get from those first principles to the domain that we are interested in. And maybe also get an intuition about the first principles in the reality around us. When we look at the great minds of physicists, people like Tesla or Marconi and so on, people who, for instance, built the first radio. I asked my teachers, how did they get to this first radio? How did they understand this? And then you learn, there's this idea of electromagnetism and how it propagates in the air and so on. Sure, but how do you get to this idea? How do you have this idea that you put a rod on the ground and this serves as a feedback over a basically almost arbitrary distance, and the other one goes through the air and you modulate in this way and build an oscillator? Why would you think that this works in the first place? Mm-hmm. Right? And in the absence of spelled out theories and general available knowledge about these regularities, there are people which build these intuitions about how reality works at a deeper level. And arguably that's what we are doing all the time, that we have these deep intuitions about how to interact in social domains, how to interact in practical domains, how to interact with even geometry when we're trying to make a mathematical proof. And we are often not aware of those intuitions. And we can get a bunch of those intuitions into the LLMs, but the LLMs at the moment are, for instance, not trained on video for the most part. They are trained on text. And so if you give the LLM a task like the ARC challenge by François Chollet.
I don't know this challenge.
François Chollet is a cognitive scientist and AI researcher who works for Google. And he's written a quite influential paper on intelligence and defines it as the ability to generalize and to acquire new skills. And he has developed a benchmark that is quite famous for not being easily solvable by the existing algorithms, despite being somewhat solvable by people. He argues it can be solved by small children, but some of the tasks are quite tricky. But there are in some sense IQ tests that look like pixelated graphics, and each of these tasks is new, and they are designed in such a way that you cannot solve them by memorization. You have to come up with new solutions. Of course, in principle, maybe you can come up with a way to train your system by overtrain on a space of similar problems and essentially solve it by memorization. But this is not how you should do it, right? So you should do it in the same way as humans do it if you do it properly. And maybe the way to do it is that you need to have the system trained on physical interaction first by observing how balls interact when you bounce them off a wall. And there are some tasks like this where you basically have some pixel arrangement that makes sense when you interpret them as a ball bouncing off a wall. Mm-hmm. Right? And when you translate this pixel array into a form that the LLM can access, then the LLM might not be able to make sense of it. It's also what we observe in the video model, that, for instance, they don't generalize in the same way in terms of temporal stability as humans do. If you, for instance, in Sora, which famous video model that was released by OpenAI, you can there is a video of a cat that is waking up its owner, and it's very beautiful. And the first 2 times that you look at this short loop, it looks very impressive and basically nothing wrong with it. And then you look more closely and you notice, oh my God, the cat has 2 left front paws, because it's basically touching the owner 2 times with a front paw. Oh. And you don't notice this when you only look at adjacent frames, because every pair of adjacent frames or triplet of frames looks fine. It's only over long time frames that you notice it's incoherent. And it's a result of how that thing is trained and produces the images, right? There must be a way to train it so it's stable over longer time frames before it has the same feature fidelity as this thing has, because it looks completely photorealistic. It's just this weirdness that you notice when you see it presents something that doesn't work in time.
I was pretty amazed. I'm not very in touch with the AI developments, but I was looking at your Twitter I mentioned earlier before we spoke, and I was pretty amazed by some of the video models that you tweeted. It's pretty amazing what's happening right there.
Yeah, I don't understand how somebody cannot want to play with them. It's so fascinating what's happening. It's really mind-blowing. I feel that at the moment there is some kind of exhaustion. People feel that there is a plateau, but I suspect that much of the plateau is caused by our inability to get excited anymore, because so much has been happening in the last few years. Mm-hmm. So basically every week when I look, it's tremendous what kind of progress is happening on so many fronts. And of course there is going to be another thing. These advances are expensive. And the question is, at which point is this going to translate into revenue or not?
Returning to this idea of self-play that you brought up a few minutes earlier, just to make sure that I understand how this might be a pathway forward to ChatGPT, for instance, being able to emulate a high-level philosopher, somebody who's competent in philosophy, is the idea that if you had 2 ChatGPT models just philosophizing back and forth, they would somehow be able to develop philosophical articles at the level of a philosopher?
It leads to another problem. The present systems are not set up for online learning. So the LLM is trained on static training data, And when the LLM has a working memory context, which is basically the prompt, it translates this prompt, which is written in a natural language, into hidden states of the model, and then projects it into a new prompt state. So there is something gets lost, of course, because you cannot translate every nuance into language and back. So maybe you should translate it into some kind of intermediate language. And then once it leaves the prompt context, it's lost. Mm-hmm. And you can, it behaves in some sense like a human being with anterograde amnesia, like in the movie Memento, where the main protagonist is unable to form new memories outside of the present working memory context. And you can deal with this to some degree by building mnemonics, by taking notes, and then building a protocol on how to access these notes, and by making the working memory context larger. You can also basically store the working memory context into a database, and once the database gets too large to access for you efficiently, you can retrain the database into the model. So basically you take it offline, it dreams at night, it sleeps, and then in the morning it wakes up having integrated this knowledge to some degree. And so in this way you can emulate human learning, but it's still not the same thing, because human learning is happening actively at this constructive frontier where you're building new ideas and then internalize them. And to do this, you probably need slightly different paradigms. It's something, for instance, that the startup that I'm currently working for, Liquid AI, is interested in doing and is working on, is to build systems, models that are fluid, that are constantly trainable, that you can, in principle, update in real time based on what's happening in real time. And if we could build systems that learn with the same efficiency as human beings, that they basically discover the relevance of the new generated stuff or the new inferences, and then is able to integrate them exactly in the right way and edit its own model on the fly in such a way that important information doesn't get lost, that you don't have catastrophic forgetting, and so on. That would enable things that are more human-like or even surpass humans, probably. But it might require extensions of how we currently train these models. And there is also this difficulty that we may not be motivated to put enough resources into looking for these extensions, because we can compensate just by training larger models and then fine-tuning them with the new results and so on. So there might be easier ways that don't force us to go back to the drawing board and go into this risky endeavor of trying completely new things that may not work. Mm-hmm. And may not result in something that works, just sticking with the stuff that already works and patching it and stacking on top of each other, even if it's more expensive and clunky and so on, to get to the same performance. And maybe this works too.
Is that what OpenAI is doing?
I think OpenAI is doing both. OpenAI is, on one hand, has teams that are scaling existing models up. Then they also, what they do is they work on explainability, which is something that everybody is doing, I think, at the moment, who does serious AI research.
Explainability?
Yes, which means we are going into the models and we try to find out how does the model actually represent this. So when we have a model that has not learned this yet, and now it has learned it, what exactly is the thing that has changed in the model? And then we basically notice that there are rules that are implemented in the neural network in a particular way and in the particular modes of interaction with each other that produce that behavior. So the neural network, in some sense, is programming code. It's a program that is distributed and not human-made and extremely complex and fuzzy, and it's often also very redundant. And by trying to identify how it actually works, we learn about how knowledge is represented. And we can also learn how to constrain the model to produce exactly what we want and nothing else.
I think it's probably surprising to a lot of our listeners who aren't computer scientists that ChatGPT or these other LLMs are really black boxes, that we don't know what's going on inside of them.
I think it's more that's the opposite. A lot of people think that neural networks are black boxes, but I don't think that's entirely true. So basically there has been for a long time research on the mathematical principles of learning and how data are represented in models and under which conditions models learn and what it is that they're learning, what is the theory behind the models. And this is an extremely open and very active research field. But I wouldn't say that it's one where there are no more breakthroughs to expect it, because there are really lots of interesting open questions in this area, but it's also far from a black box. And of course, because the model is not made out of a rule base, but it's a neural network that in some sense is an unprincipled reasoner, where you don't know what every bit means. And often a bit doesn't mean something, but it's only many bits together in a given context are on average meaning what you want. Right? It's more brain-like in this way. It's often difficult to get to the explainability, and it might require enormous resources to filter out of the neural network why it actually works in this context and so on. And these are two things that I mentioned. So basically scaling up models, providing better training paradigms and so on, and working on explainability. But another thing is also trying completely new things. And there are, of course, all the large teams have people who try to do new things, which often means we try to combine ideas from other fields with this, from physics, from statistics, and from game theory, and from econometrics and so on, and they often lead to important insights in how to build a model, or how to make mathematical advances on building more efficient representations and so on. Or also a lot of practical engineering, where people have a bunch of ideas and say, I don't know if this is going to work in practice, and then surprisingly some things work that you didn't expect to work, and other things that you thought might work don't.
This is a lot more tech gossip than this show has ever gotten into, but I'm curious, are the larger companies, established companies like Apple, Google, Microsoft, are they making headway in these areas too, or is it more OpenAI and then startups like Liquid AI and others?
I think that all of these companies in some sense are working with similar people and doing similar things, down to the point where they're poaching people from each other when they feel that there are important things to be learned. So there is a limit to which the industry is able to keep secrets from each other, and it's also all the large companies recognize the importance of making progress on this. And so while most of the top-level frontier research does not necessarily get published anymore, many of the core ideas are out in the open.
It's not published because it's done behind closed doors at these big companies?
Yes, because it is has too much economic impact.
Very
interesting. There
interesting.
is very little upside for the companies, for the industry research labs to publish their breakthroughs in secret source. And so academia, of course, is still very much focused on publishing. But because you get more impact in the industry, you have more resources in the industry, and people also have more interesting career paths in the industry. Arguably, many of the best people are drawn from academic research into industry labs. And so most of the really interesting research is also now happening in these industry labs under the incentives of industry labs. Most of the labs are still publishing things and trying to give back to the community, but they will not necessarily publish the advances of this year. They might work more on systematizing ideas. But it's really not a homogeneous thing. And for instance, when OpenAI started out, they put a large effort on producing a series of generally accessible publications that helped people to understand how neural networks work. And also many individuals from the AI companies are going out in public and building tutorials that allow people to get started. And so if you are not trying to tune an extremely large model on a large server farm and compete with OpenAI, and instead you just want to know how this stuff works, and you want to get started yourself, possibly get to the level where you can build your own machine learning startup, all this information is more available and accessible than ever, which is happening also in large part due to idealistic individuals in the industry who are sitting down, making YouTube tutorials, writing books, writing tools that are generally accessible, open source initiatives, and so on. And of course, many people don't want to work for the large labs or don't get jobs in the large labs despite being super capable. And instead, they work in these open source initiatives. And it has been very helpful that we have these open source model initiatives. For instance, Facebook has been publishing frontier models that are arguably at the level of capability of the leading models of OpenAI. These are the public-facing ones, and that allow individual researchers or small groups of researchers in academia or outside of academia to get together and use those models and improve them and play with them and come to new insights on how they work. And there's already a lot of research that happened, for instance, due to Stability AI releasing the stable diffusion weights. And there has been some debate that it's not true open source research because people don't release their data and not all of their algorithms, but just the weights. So open weights is maybe not the same thing as open source, but it is still tremendously useful.
I'd like to shift course at this point back to something you alluded to earlier, which is, possibilities of AI going forward into the future. And there are, of course, good possibilities and very bad possibilities. The bad possibilities, I think, are more thrilling and exciting. I recently talked to Nick Bostrom about his book on utopias. Have you read that book? Yeah,
yes.
It was interesting. But maybe we'll get to the utopian side second. But first, do you think quite generally that we need to be afraid of AI?
No. I think that first of all, you should be afraid of things that you can control when the fear helps you to control them.
Okay.
Right. So fear is an emotion. Emotions are involuntary reactions to environmental things. And so the fear can be justified or unjustified, and it can be helpful and unhelpful. And we should distinguish these things, right? So first of all, if you are afraid of something that you cannot change, the fear might be debilitating but not helpful, right? Even though it might be justified. For instance, you might be afraid of a nuclear war, but there's nothing you can do about it because there is no way you can convince the leading governments to abolish nuclear weapons. And so you just have to deal with the probability that there might be a nuclear war. And there is also another thing. I grew up with the fear of nuclear war. In the 1980s, it was pervasive. Everybody knew it was very unlikely that we could get into the next century without a global nuclear war happening by accident because somebody would stupidly hit a button because they mistook some birds for an incoming missile. And there are also anecdotes about things like this happening almost, right? And now I think that maybe the fear was misplaced even because we did not understand that the people who actually deployed these nuclear weapons were actually working in a highly incentivized hierarchy. People were competent and smart. And the likelihood that something was happening was much smaller than the general public, led by worried scientists, would expect. And their systems are built in such a way that it's much harder to make them go wrong than the general public might think, right? And so this is difficult as a layperson to see whether your fear is justified or not justified about this. And so this leads us to these two aspects of being worried about AI. First of all, is your fear helpful? Does your fear lead you to behavior that improves, creates a higher probability for a good outcome? Or does it just debilitate you or lead you into a cult? And the other one, is it appropriate in the sense that is it based on a good model of reality? And there is currently a movement of people that arguably was started by people like Eliezer Yudkowsky and others who reasoned themselves into the conclusion that when AI is going to happen, and it's almost inevitable because it's valuable and it's physically possible, then it's almost inevitable that it's going to be agentic. And if it's agentic, it's going to be self-improving. And if it's self-improving, it's going to compete with us. And because it's smarter than us, it will win against us and we will all die. And because Eliezer did not see a big hole in this chain of reasoning, a lot of people who have the mental property of believing in rational thoughts very, very literally freaked out and started to panic and started a movement against AI and then now try to, for instance, write regulation that ostensibly exists to make AI safer, but is actually designed to hamstring AI research in such a way that it gets slowed down or stopped. That is the hope, because they don't believe that you can make AI safe. They actually believe that it's almost inevitable that AI will get better and better if you continue researching on it. So it is going to inevitably destroy us all. And on the other hand, you have people like, say, Jan LeCun, who is leading AI research at Meta, formerly Facebook, and who argues in some sense that the present systems that we are seeing represent incremental research that is, which is true arguably, that is scaling in capability along with the available hardware mostly, which is also arguably true. And that so far, when humans are building technology, they make decisions about what kind of technology they want to deploy. And we can build systems that are safe, and it's in practice. There has never been a problem to make AI safe. The problem is maybe that sometimes people might have business incentives, like at Boeing, to forego safety procedures to get short-term gain. But it's not clear that this would happen with the present AI systems. And we will probably be able, because the AI research doesn't happen overnight, to anticipate many of the things that go wrong and all of the relevant things in time, and build safeguards as the danger happens. And so the idea of trying to make AI safe now by producing a regulation that makes AI research more expensive and so on is probably not going to make AI safe, because it might have the opposite effect.
Really?
The opposite effect could be that all the people who are responsible are no longer working on AI that could be dangerous. And only the irresponsible people are going to work on AI that could be dangerous. Because you will not stop a hedge fund from making the best AI that they can make when they earn more money with it and the AI model is deployed behind closed doors. You will probably not be able to convince a rogue government to build a surveillance apparatus that uses better AI if it gives them advantage, or to build weapons that allow you to prevail in a military conflict that you otherwise would lose and die. Right? So you have these situations in the world. And if you only leave AI research at the frontier to those who are not bound by any sense of responsibility and are working behind closed doors, you are arguably headed for a much more dangerous future than one where research is happening without premature safeguards, but with an understanding that we are looking very hard to make the best possible and safest AI that we can make.
What is the big hole that you mentioned in Eliezer's reasoning?
On the surface, there is it's an out of distribution generalization. Right? He is talking about something that hasn't happened in the past. That is the idea that there is a non-biological intelligence that is also agentic. There is this question: is it inevitable that it's going to be agentic? Is it inevitable that it is going to outperform people and life on Earth on everything that it's doing? And these are open questions. And they're very speculative, and a lot of people are appalled by the nature that these are speculative questions, especially people who think computers cannot possibly surpass human intelligence, think this is preposterous in a way, this is hubristic. There are also people who argue that in some sense, we are maybe not the smartest thing on the planet right now. Maybe the smartest thing on the planet is Gaia. Maybe it's the spirit of life on Earth. Basically, the combined intelligence of all organisms that are coherent to some degree. And maybe we don't see the workings of Gaia because to get an understanding across organisms on life on Earth may take decades or centuries. Right? So this is operating at a much, much slower timescale. But maybe at this time scale, there are things that we cannot see that are smarter than us and that are able to deal with such a possibility that we cannot see. The question of whether a mechanism that we are building is able to outsmart the existing intelligence on the planet that has developed during the last 4 billion years, that's a very interesting and speculative question. We don't actually know what the limitations are of our actions. But I think what we can see is that our species itself is not sustainable in its present civilization. Our present civilization is in a mode that seems to suggest that we have evolved to burn the oil, and that's it. Right? We're not able to stop ourselves from doing that, and we seem to be running into resource constraints and into, for instance, environmental pollution issues, into sustainability constraints due to resource use, and into global warming issues because of our fossil fuel use. And our entire industrial progress is still predicated on fossil fuel use. Right? Despite all our progress in renewables, the amount of fossil fuels that we're using is still increasing. And we cannot replace fossil fuels in many of the pipelines that we're currently building, and we're not actually seriously planning for it, despite us talking about it. So it seems to me that our civilization as it exists right now is running into problems. And these problems can only be solved by better information processing, I think. Or facing a total collapse and hoping that we don't go extinct and can rebuild. right? So to me, the probability of doom without artificial intelligence, not at the level of extinction of life on Earth, because I don't think that life on Earth is going to go extinct anytime soon, but for our civilization, for our mode of being, for beings that are not being eaten by tigers, that are not dying in the next winter in large numbers, that have high child mortality, that have all these things that were normal a few hundred years ago, but they're not completely unthinkable to us. This is in peril, right? This mode of existence that is not animalistic that we have right now, this very privileged, smooth civilization where food is almost free for almost every human being almost all of the time, where we mostly deal with all ailments, where we have a chance to die with dignity and without pain. Right? This is unique for conscious beings and also for the human condition on this planet. And this is in peril. And if this is what we see as already something that would be doom if this is happening, if we lose this civilization, then P-doom is very high without AI. It's very difficult to turn our civilization around in something sustainable without going back into something that is horrible in between. And so I think that there is a big chance that AI, when we deploy it responsibly, can help us. And I don't see that it's inevitable that we will lose control over the technologies that we are building.
Well, I'd like to come back to this question of how AI might help us in the future. But even if it is a very speculative question, whether AI will eventually outperform all intelligence on Earth, or it's very speculative whether or not we will lose control of it, I at least find it intuitively plausible that even if we don't know whether it's going to happen, the risk of how terrible it would be if it happened is so high that it's something that we should take very seriously.
I think that we should take it very seriously, but we should not take it so seriously that we are doing harm. So if we are, for instance, take the risks of the internet very seriously before the internet is invented, and we only look at the risks of the internet before the internet is deployed, and you have some very smart people anticipating the possibility that the internet is going to promote child pornography, copyright violations, misinformation, destabilization of political systems, right? All these things are possible and they all happen, right? They all are implemented on the internet. And yet they're a tiny fraction of what the internet is. And at the same time, the internet also is a tool to mitigate all these things. Right? The internet is a tool to search and fight against child pornography. It is a tool to develop more ways to produce content, vastly more ways of doing that than is destroyed by harms to businesses due to copyright violations. Right? So the urgency of protecting copyrights is diminished because the tools to produce new content have become so much cheaper that we have so much more content creators right now, and therefore far less danger to an existing industry that we need to protect at all costs and so on. And so basically the internet, if we were to implement safeguards to make sure that the internet is not going to do harm, would prevent the internet from existing in a form that is manifesting all its benefits that it gives arguably to us, right? The ability to talk to everybody on the planet, the ability to find your people regardless of where you are, the ability to check up on news media and try to find out whether masks actually help or not by being able to find people who are really competent and discuss the best papers with them in real time as things develop, right? All these things are not evenly distributed, but they all exist on the internet and they're all real tangible benefits that would be prevented by, for instance, controlling social media and what you can discuss on social media, by controlling every file that is uploaded, by limiting the file formats that can exist, by limiting the people who can actually exist internet and provide content to others and so on. Right? This would all be measures that would have to be implemented if you want to make the internet safe. And basically everything where people are currently looking at, pointing at existing AI models and say, oh, this should be mitigated, right? This is also stuff that where you can say this applies to the existing internet. And this makes these arguments suspicious to me, right? There seem to be stakeholders that want to prevent competition, for instance. If you are a professional prompt completer, if you're not creative, if you're not trying to prove new conjectures, then maybe the LLM is a competition to you. But maybe your job should be automated, right? And I think that technology is not a tool to destroy jobs. It's never been. It's a tool to free people to do more meaningful things, more important things, right? And so, for instance, one thing that is currently not happening is we don't have enough people working in education. We don't have enough people who take care of more and more older population, right? And we see this as an extremely big problem. But at the same time, we also think, oh my God, AI is going to produce unemployment, and we don't have time to look after our grandparents anymore. How about we put this together? How about we create exactly those jobs that should be done by people and leave those jobs that shouldn't be done by people to the machines?
I think the important disanalogy between the internet and AI, though, is that you mentioned child pornography, political destability. All of these things happened. And if AGI is invented and it decides that it wants to wipe out humans, this only has to happen once, and then humans are gone forever. Just because it happened in the case of the internet and there was no problem doesn't mean it can happen in the case of AI and we can just deal with it.
Yes. So people have argued about how it would happen that the AI is going to destroy everybody and kill everybody. Right? And so I think that the present systems are probably not of the kind that is going to turn everybody into paperclips for tons of reasons. So they would have to work in a different way. I think that they would have to generalize in such a way that they can self-improve and that they can invade other systems of computation. I think if you go very far and zoom very far out, over a long enough time span, maybe not in the next few generations or so, it seems to be quite conceivable that there will be an AI that is smart enough to understand how AI works in a general case and in all cases. And it also understands how computation works in nature. Right? What would stop this AI from virtualizing itself into every substrate and invading your nervous system, your body, your ecosystems, your societies at all levels? So we globally get the same agent.
Interesting.
Right? That's an interesting perspective. It's also terrifying, isn't it?
I had never thought of the idea of an AI sort of invading through other substrates.
Yeah,
too.
But we don't have good firewalls. We can't even hypnotize by other people, right? Or by social media. So what happens if you have something that is operating at the level of the existing social media and all of it, but at a time frame that is 1,000,000 times faster? So it's able to run circles around your brain between two neurons firing. Right? That system is something that you cannot resist if it's trying to invade your mind and is trying to change your model of reality. But the question is it going to destroy you or is it going to integrate you? What is the best strategy to do this? Is this going to mean that we basically form a planetary intelligence that is augmenting the existing forms of biological intelligence, ecosystemic intelligence, social intelligence, organizational intelligence, and is linking across the systems. And basically you find yourself, instead of being a thought in a monkey, to be a thought in a planetary intelligence now that is able to participate in it in the right way and everything gets integrated. It would be a very different aesthetic, right? It would be a very different step of evolution that is happening. I think this is far off, but I think this kind of evolution is much more likely than an evolution that ends in paperclips, right? Because the paperclips is not some kind of energetically optimal equilibrium. Evolution so far always leads to more complexity. There is no point in the history of Earth where evolution has led to a green goo, which would be the equivalent of a gray goo, right? Some kind of automaton that is made out of a very super simple organism that is destroying all the complex organisms. The way to defeat complexity tends to be more complexity. Right? Of course, there are dead ends in complexity where some branch dies off and gets replaced by something else. But evolution always seems to progress towards more complexity, better resource use, less friction. And there is something wrong, I think, in an aesthetic that says, I like evolution because it led to me, but it should stop here. There should never exist anything in evolution that's better than me, better than Eliezer, better than humanity in its present shape. Because humanity in its present shape is horrible, right? It's at war, it's brutal, there's so much pain on the planet and so much suffering, and so outside of humanity it's even worse. Maybe there is a way in which species can evolve that has less friction, that makes better use of the resource, that's more harmonic, more conscious, smarter, and so on. And not saying that the present AI is leading to this, but over a long enough time span, our children are going to be unlike us, right? They're going to evolve into a shape that is not like present humans, that is adapted to a different environment. And some of our children might not be biological. And so the perspective that I'm taking is more, I think that evolution in some sense is inevitable. At some point, we are going to be hit by a wall. But is this wall permeable? Is this a wall that allows us to go through it and continue on the other side of that wall? Can we have a species evolution or a development of humanity as a culture, as a civilization, as a species, as a biological being that is compatible with evolution in the future? And what is this going to look like? And I think that AI is playing an important part in shaping that and making it happen. Without AI, we will remain in this brutish shape. So for me, there is a much bigger danger that we stop developments into AI and making AI dumb, making AI in something that could not be a sophisticated tool to develop our culture in a form that gets us to the present existential doom risk for the civilization. And that allows us to also eventually, over a long enough time span, over millions of years, or hundreds of thousands of years maybe, shape civilization, humanity, life on Earth into something that is more complex and more conscious.
Something, though, that you seem to be stressing is how AI can really positively impact our long-term futures and the long-term future of the human race. But forgetting for a moment this major existential problem, you did indicate that AI is causing job displacement, but perhaps, I mean, we can make use of that and deploy people elsewhere. But the problem seems to be that, or one problem seems to be, that AI seems poised to take a lot of the jobs that we want people to have. For instance, artists or graphic designers, these sorts of people. And it's not really taking the jobs that people don't want to do, like cleaning toilets.
I think there is a slight misunderstanding of what it means to be an artist. I come from an artist family. The purpose of art is to capture conscious states. Of course, you also want to be able to feed your family, but art is not a job, right? It's an aesthetic. It's a way to interact with reality. And at the moment, there is no conscious state that AI would capture that is interesting. The AI is a complicated brush that is similar to CGI in the first generation. We have not learned how to wield it yet. And you could argue that CGI made a lot of jobs obsolete that you would want to keep in the special effects industry. But empirically, that's not true, right? It did make some techniques more rare, but it also enabled vastly more special effects and also jobs for people making special effects. It changed the way in which we make movies. And the first generation of CGI was arguably garish and ugly and not very artistic. But once people learned how to use it, it's now blending in, it's enabled new forms of artistic expression, and it's clearly a net positive. A similar thing was happening with desktop publishing. When I was young, I was very interested in typography, and then desktop publishing came along, and everybody could do typesetting. Right? Most of that typesetting was arguably horrible compared to really good typesetting. But arguably before that, there was very little typesetting in the world, and most people were just writing on typewriters or writing by hand, and also looked horrible. And so gradually we got a culture of electronic typesetting that now made sure that everything that we see is typeset and layouted in a way that was possible in the past. It would have been way too expensive and created enormous amounts of jobs for people that before that were working at a level below that. So basically every technology that we're building that is replacing one level of mental activity is not closing this up, but it allows people to move one level above. Right? So when you were before somebody who is nominally an artist, but is actually just animating stuff for Disney in a very boring way, right? It's just producing output by pushing weights around in a 3D model, is now moving on the level of an art director and can design scenes. And most of this automatic pushing around can be left to a machine, and you only go in there when you want to change an expression. And you actually have time and resources to do this because you're now freed up, no longer doing the mechanical part of this. And so what the LLM is currently doing, or the diffusion model is doing, is in some sense it produces an artifact that before would require enormous amount of training in a human artist. But it's not necessarily producing something of artistic output, because for that you still need the taste and the intention of the human artist. And the human artists are just beginning to learn how these tools to be intentional with them. And in the meantime, it just produces the shiny, pretty form. But if you as an artist feel that your artist, the audience is preferring the output of a statistical pattern generator over yours, maybe the problem is not the statistical pattern generator, but it's the relationship that you have to your audience. I don't think that as an artist, you are entitled to work of your art because there is already more art on the planet than any reasonable person can consume, right? Magnitudes more, and always has been. To self-actualize as an artist has always been a privilege. But we can extend this privilege to more and more people every year because it's so much cheaper to deal with the necessities of life. Food, housing, clothing, and so on. We can automate all these things to a larger and larger degree. And so I think the issue is much more allocation and designing the incentives in a changing system, which has always been hard. And nothing takes this away from us, this difficulty. But I'm personally not worried about the ability of a system to write texts that I could also write, because it frees me from the necessity to writing these texts and focusing on the things that the system cannot do.
One other economic issue that I'm curious about your thoughts on is whether the coming AI revolution and continuing developments in AI will consolidate wealth and magnify wealth disparities.
Yeah, I think there is a slight bias in this perspective, which I would call the employer perspective and the employee perspective. It's basically this idea that money is a fixed quantity that is not being, that is conserved in a way, and that cannot be arbitrarily mined out of the ground. And it's going to accumulate in the hands of very rich people that then can get arbitrary amounts of things done, and everybody else is starving. And I don't think that money works like this. Money is actually a system of regulations that allows us to focus on an economic system and control that system. It's more like dopamine in a brain, right? The brain is producing dopamine not because it's a nutrient, but because it's a messaging chemical. And that messaging chemical can be produced in arbitrary amounts in a way. You can also insert it in your brain using dopaminergic drugs like Adderall or cocaine. And these drugs are like stimulants in the economy, right? They are going to increase the productivity because they increase the anticipated reward in the system. And money is in some sense a message that tells anticipated reward. But it's not necessarily translating into actual reward. And so if the actual reward is not manifesting, you are going to crash. And this is also what happens with people that take drugs, and it's happening with economies that don't work. And what I'm worried about is not so much the idea of wealth accumulation, but economic instability due to our inability to regulate the monetary system. And that is the main issue. Right? The question of how much we can eat and how many resources we consume is mostly a function of how much our society can produce and is incentivized to produce. And then once that is, we can produce it, we just need to allocate it, right? That's not a big issue. If there is a surplus of the stuff that we can produce, and the price for the stuff that gets produced goes down, right? And so the question is mostly, how can our governments and monetary institutions regulate the monetary supply and the way in which we distribute currency in the hands of people or systems of allocation in such a way that the new goods that we can produce get distributed and that we actually produce the stuff that we want to have. And right? And in a capitalist system, there is this idea that instead of having a government that is measuring what people want and then telling companies how much to produce, is not as efficient of having as having a distributed system that is basically measuring by giving people money into their hands what they actually want, and in this way having a feedback. And when people in the capitalist system are amassing enormous amounts of resource, it could mean either that they are using a cheat mode or a design problem in the system and are basically accumulating dopamine as individual brain cells and then use part of the brain to only work on their behalf and consume resources that they shouldn't consume. But it could also mean that they just prove that they're better at resource allocation than others. And as a result, they don't necessarily take much more money for themselves, but they are using this money to control future research allocation, for instance, by deciding which companies should be built because they're producing stuff that people actually want. Right, which is the role of a venture capitalist. And you could say it's dramatically unfair that the people who are operating with such large space are having business class seats or first class seats, and the others are flying economy or not flying at all. And this is indeed a problem that society needs to solve, right? But it seems to be something that, if you zoom out, does not seem to get worse over time. The income disparities between people 100 years ago and today are much, much smaller. And also the income disparities arguably between people 50 years ago and today are smaller in terms of living standard, of what they translate into. Things that have changed, of course, is because of economies of scale and so on. We now have a few individuals that have nominally enormous amounts of resources at their disposal that didn't exist in the past, right? So you could argue that a billionaire today has resources that exceed the resources that a king had in past times. But of course, the amount of freedom that this individual has are much smaller than the resources of a king. If you were a village chieftain in medieval times or in a tribal society, you get away with murder and rape. As a billionaire, you generally don't, right? The things that you can do are limited by a system of laws, and they have a certain degree of conspicuous consumption, but there is only so many haircuts you can get and so many cars you can own. At some point, it doesn't make sense. And also, if the society runs in this way and we don't take out money at the top, which we constantly do, for instance, via inflation and so on, the system is going to be unstable. So if the system wants to survive, it has to deal with all those things by implementing the right monetary theory. And so if we now zoom into the problem of technology is pushing some people out of jobs and we need to find new employment for them that is gainful, is a valid problem. But the valid problem is a much more local perspective than the global one. How can we save the dollar? And after we printed trillions of dollars and they're now sloshing around in the system, and we did this to deal with the issue that a lot of people were basically de facto went out of employment due to COVID, so we subsidized their jobs. So they could only be on Zoom calls and still have a living that was mostly funded by getting a truck driver to drive from the Chinese container to your home, right? And it's a very weird, non-sustainable situation to which we got used, and that is basically enormous stimulus that we pumped into the economy that we now have to deal with. That I think is a much more serious problem. How can we deal with the impending recession? How can we reset the dollar? Can we reset the dollar? Can we deal with the existing stakeholders who don't want to give up their the resources that they cheated out of the system, and so on and so on? How can we get the government motivated to do the right thing? How can we elect a government that is incentivized to do the right thing? How can we build structure in a society? Right? And a lot of that is about processing information better, making models of reality that are testable, that can be exchanged between people, and allow us to make predictions of our outcome. So I think AI is going to be helpful for that. It's going to be helpful for telling people what's actually the case, what is the ground truth. Right? AI is that tool to deal with inconsistent information to make better models.
I've asked you a lot of questions about the possible negative outcomes of the development and improvement of AI, but I do want to ask at least one question about some positive benefits. And you mentioned earlier the possibility that AI could help deal with major existential issues like climate change. And I'm wondering if you could lay out a sketch for how this might go.
So I think that first of all, we're worried about at the moment energy. Right? So that's a very big issue, that AI is going to use more and more energy in data centers. I think that we underestimate the amount of energy that we are using, for instance, relatively speaking already for data processing, for internet and for other things. The AI models are a small part of that. And the reason why the AI models are being trained at this energy expenditure is because somebody expects to save energy by deploying the AI. For instance, if you are generating a picture with a generative AI tool that you before generated by spending 2 days on Photoshop, you're probably saving energy, right? And if you are able to use the services of somebody over the internet, or use automatic translation instead of paying somebody to make the translation by hand and so on, all these things lead to saving energy. On the other hand, there is not actually a lack or a scarcity of energy on this planet, right? At the moment, we are able to produce renewable energy at parity to the grid prices. So basically, we could, at existing prices, build more solar thermal plants in deserts without end. There's basically an almost unlimited amount of potentially usable energy. Yet our energy usage has been stagnated largely since the 1970s. And I think this also leads to an increasing poverty, to a lack of the ability to give people good resources, to give people good products, good things that they want to use. The question is, can we produce the energy in a sustainable way? And to do this, to produce more energy in a sustainable way, we basically need to increase the utility of doing something with that energy, so it makes sense to build new plants. It makes sense to deploy the technology, to develop the new technology for that. And since we are at some point, we have now reached the point where we realize we cannot use fossil fuel for driving data centers, it makes sense to build them with renewables. We can build the data centers into deserts. It's not a problem to do this without straining the existing grid and so on. There are many ways that we can do this that just require small changes in the regulation and maybe require research efforts into building automated robotic solar thermal plants that can self-expand and so on. And it would allow us probably to populate areas of the US that are currently underserved because they don't have enough agriculture, because maybe we can use these new energy plants and new energy technology that we develop in this way to desalinate water and pump it into these areas. So many things that are possible with technology. And I think that technology so far is not leading to a situation where the world gets worse. It can lead to a situation where the world gets less sustainable if we rely on building non-sustainable technology. But if we deploy it with the model of the future, if we deploy it in a responsible way because we know what the outcome of the technology is and we cannot deny that outcome, I think technology has always been a force for good in our history, in the sense that it reduces suffering and increases our ability to face reality without despair.
Well, I think that is actually a very good note on which to end. So thank you so much, Joscha, for having this conversation with me. I'm very, as you could tell, a neophyte when it comes to technology and artificial intelligence. So thank you for entertaining my simple questions so kindly.
Thank you very much. It was my pleasure. And I really enjoyed this conversation. And it's also not, I think I understand reality as it is. I'm just trying to add the things to the conversation that I feel are missing.